Dear students, I have come with a new module, Elements of the Probability Theory or Introduction to Probability Theory. So the outcome of a physical or chemical experiment is certain. That meaning, if you are adding sulfuric acid to zinc, you know that what will we get as a result. So that physical or chemical experiment, the outcomes are certain. But the results of social science experiments are uncertain. We don't know if tax rate is increased, how much will be the impact on savings. We cannot predict it. We can make some calculations, but it's not 100% certain. Or the sex of a newborn baby, tossing of a coin, where we'll get head or tail, or when you toss a dice, can have any outcome 1, 2, 3, 4, 5, or 6. So, which one you're going to get? The result, you have to wait for that and you have to see that what will be the result. So there is an element or chance of uncertainty in social science experiments or in any social science situation. So a numerical measure of uncertainty is provided by a certain branch of statistics that is called the theory of probability. So theory of probability is associated with statistics. So I'm going to explain that how it's related. We know that many statistical surveys, we are doing sampling. So sampling survey, it has a relationship with the probability because it's related to a chance. So the theory of probability, how it introduced. So theory of probability has its origin in the games of chance related to gambling. Gambling, you know that it's a pure luck. You will predict something. Whether you will get that or not, it's pure chance. So Theorem Cardan, an Italian mathematician, published the Book on Game of Chance. So this book was published after his death in 1663. So this was the initial introduction of the concept of probability. So systematic and scientific foundation of mathematical theory of probability was laid by the French mathematician Blaise Pascal and D. Fermat. So this is how from 1663 how this subject is introduced. The contribution of Swiss mathematician James Bernoulli. His contribution is also worth mentioning, and probability has become one of the basic tools of statistics. So these people contributed to the theory of probability, and now probability and statistics are closely related and closely related and interconnected also. So probability theory helps to interpret the statistical results, because I have already mentioned that statistics we are using sample surveys. So sample surveys are also affected by chance differences. See, for example, if I'll give you the explanation that when I was doing my PhD survey, it was about saving habits. All the respondents I contacted and I collected the information, they were for savings. They have to, whatever money, whatever salary they're getting, they have to save a certain percentage. That was their response. But I found two people, they're totally against the concept of savings. They were telling me that India should be like a Western country where social security is provided in the foreign countries. Like that concept should be introduced in India also. This was in 1990. So nobody can explain this, why these people are thinking totally out of the box. Two respondents I am getting which are totally against the concept of savings. So here it's always chance differences will be there whenever we will study something. See, some people will have good things to talk about COVID. Some people, 99% will have to talk about negative things about COVID. So this is the thing, chance differences will be there. Anything you study, so chance differences will be there. So thus probability theory helps us in including numerical uncertainties in statistical conclusions. So uncertainties are related to social science studies. So this concept of probability will help us in solving this issue. Now, if you see the quotation, according to Professor Ya-Lin Chu, statistics is the science of decision making with calculated risk in the face of uncertainty. So probability is placing an important role in this. Chance differences are there, uncertainty is there, and probability is helping to solve the statistical problem and to make us the correct assumptions or the correct decisions. Now, basic terms used in probability. Three terms I'm going to use. One is random experiment, second one is sample space, and the third is event. So, random experiment, an experiment in which outcome is unpredictable. So, this you have to remember that if you toss a coin, you don't know whether you will get head or tail. So, that is outcome is unpredictable. So this is true any number of times the experiment is repeated. How many ever times you toss that coin, you will not know how many times you will get the head or how many times you will get the tail. So this is why the random experiment is called the chance experiment or probability experiment. So examples: tossing a coin, tossing a dice, or playing cards. From the 52 cards, if you want to take one, you don't know which one you will get. It can be anything out of the 52 cards in the pack. So tossing a coin, the outcome can be head or tail. So when you're tossing a dice, it can be outcome can be 1 to 6. If you're taking a card from that, any 52 card, anything can come as an outcome. Then sample space. Sample space is associated with random experiment is a set of all possible outcomes. So whatever the outcomes possible, if you're tossing a coin, head or tail, if you're tossing a dice, 1 to 6, that can be the outcome. So the sample space is denoted by the alphabet S, capital S. So if a coin is tossed, outcomes can be head or tail. So S is equal to head or tail. So S, you can, short form we are using, S is equal to H and T. For calculation, we always use the short forms. So tossing a dice, the sample space or S will be 1, 2, 3, 4, 5 or 6. So sample set is finite. We know that either when you're tossing a coin, it can be or head or tail. When you're tossing a dice, it can be 1 to 6. So it's finite, it's certain. Now the event. The event is the subset of the sample space S. We have seen that S is the sample space and is denoted by the capital S. So in an experiment of tossing a pair of different coins. So if you have one coin, then you know that it's head or tail. But when it's a pair of coins, it can be two heads, two tails, one head and one tail and one head are the possible outcomes. While tossing a coin, the outcomes are head or tail. That meaning if a single coin is tossed, then meaning head or tail will be the outcome. So event head or tail has occurred. If a different toss coins, meaning that outcomes will be different. So event is the subset of sample space S. So the subsets, two heads, head and tail and head, and two tails are called the elementary events of the experiment. So this is what I want to explain as the introduction to the theory of probability. Thank you.